All right, guys, so we're going over the review sheet today. Going over the review, finishing going over the review. So we started on the review Friday. It's already posted. The full review video has been up. It's actually been up since Thursday. So we stopped on 19, yes? All right. All right, guys, let's focus in, focus in. So we're going over the review sheet today. We're starting with problem number 19. X squared minus 3x minus 40 over x squared plus 8x minus 20 is being divided by x squared plus 13x plus 40 over x squared plus 12x plus 20. The first thing when dividing rational expressions, we want to keep the first one the same. We want to change it from division to multiplication and flip the second expression. We keep, change, flip. Keep, change, flip. And that's the first thing we're going to want to do with any of the division problems. We want to keep, change, flip. Before we factor, before we start doing anything else, we want to keep the first expression the same, change it from division to multiplication, flip the second one. And after we do that, we're going to factor all four spots, the two numerators, the two denominators. Now, if they're already factored, if it was nice enough and it wrote it already in factored form, we don't have to do any factoring because it's already been factored. At that point, we just need to multiply and then simplify. However, here, we do need to factor both numerators and both denominators. I'm going to start with x squared minus 3x plus, or minus 40. Since the third term is negative, our signs are opposite.
Colton Martin, Gail Jackson, I predict Gingrich, Angel Moyer,
Okay.
Alright. I know exactly what the bail money's in my
All right. Now, I did skip over this. There is no greatest common factor. At this point, for the most part, I end up skipping over it because if we don't have one, here we don't. Factors first and third term. Well, the factors of x squared are x and x. Now, our factors of 40. 1 and 40. 2 and 20. 3 is not a factor, but 4 and 10. 5 and 8. The first ones I want to use, or we're going to use, is 5 and 8. Now we can check and make sure that these are the correct middle factors or the correct terms. X times negative 8 would be negative 8x. 5 times x is positive 5x. Positive 5x minus 8x, negative 8x plus 5x is negative 3x, and that is indeed the middle term that we wanted. Now from here, it doesn't matter where we go next. I'm just going to go to the denominator of our first rational expression, x squared plus 8x minus 20. Again, no greatest common factor between these three terms. But since the third term is negative, our signs are opposite. The only factors of x squared are x and x. Factors of 20. 1 and 20. 2 and 10. 4 and 5. Now to get that middle term of 8, probably going to want 10 and 2. Now doing 4 and 5 would give us an x plus 5 on top and bottom. However, that would give us a positive 1x or negative 1x middle term. Here, we get negative 2x. 10 times x is positive 10x. giving us that positive 8x that we wanted. Now, the first rational expression really didn't give us any hints on top and bottom. There weren't any common terms, no like terms. But as we go to the next side, our x squared plus 12x plus 20, since the third term is positive, the signs are the same and match the sign of the middle term. So we get plus and plus. Factors of x squared are x and x. We already have the factors of 20, 1 and 20, 2 and 10, 4 and 5. And we would want 2 and 10, because now we do have something in common on top and bottom. And if I do check this again, x times 10 is 10x, 2 times x is positive 2x, giving us the positive 12x middle term that we wanted. And then our last expression, x squared plus 13x plus 40. No greatest common factor, and since the third term is positive, our signs are the same and match the sign of the middle term. Only factors of x squared again are x and x. And the factors of 40 that we want are 5 and 8. And if we check this here, we would get 8x plus 5x, giving us 13x. We can hear you all the way down the hall.
We got waterboarded.
All right, guys. All right, guys. All right, guys, focus in. Questions on how we got these 4 expressions factored? Now, at this point here, we just need to multiply them together. Now, we can go and say that we have x plus 5 times x minus 8 times x plus 2 times x plus 10 on top over x plus 10 times x minus 2 times x plus 5 times x plus 8. Or we could have gone. Either way works, because we don't really have any monomial terms to rewrite. We're not going to get them lost in the dead center. We could do either way. They both work. But we do know that a few things are going to simplify. On top and bottom, the x plus 10 and x plus 10, x plus 5 and x plus 5, leaving us with x minus 8 times x plus 2 all over x plus 8 times x minus 2. Now, we can't factor out a negative from the x minus 8 and get x plus 8 because both signs aren't opposite. Factoring that negative out of x minus 8 would give us negative x plus 8. Still not the same, doesn't simplify. This is as far as it goes. Questions on this here? If everything had canceled on top and bottom, had simplified out on top and bottom, what would we have gotten? If everything simplifies, it reduces to 1. And if everything canceled on top and bottom, it's just going to reduce to 1. Questions on this here? Do we want to look at 21 or 20? 21. Whenever we add 2 or more fractions together, the denominators have to be the same. Doesn't matter what they look like. No, they just have to be the same. If they are the same, we can add or subtract the numerators. Here, all three denominators are the same, and they're all 3x plus 2. So that means we can go straight to adding the numerators to adding or subtracting our numerators. In this case, we're just going to add all three because it's just plus, plus, plus. Now, since we are just adding, realistically, we don't need the parentheses. The main reason we put the parentheses is in case there's any sign change. Especially if we're subtracting, we have to distribute negatives. Signs are going to swap. Here, since we're just straight adding, none of the signs change. And we end up with 9x squared plus 6x minus 1 plus 6x plus 5. All over 3x plus 2. Now, when we combine like terms, 9x squared is going to be 9x squared. Okay. Yes. Yes. Now the 6x plus 6x is going to be plus 12x. And lastly, negative 1 plus 5 is going to give, you can just put it on my desk, 4. Questions on how we factored or got to this point here? Now we could say this is the final answer as long as nothing factors and nothing reduces, because at this point the 3x on bottom and the 9x squared on top won't cancel because we have that plus and minus. We have all the pluses on top. Nine x squared plus 12x plus 4 will factor. Since the third term is positive, the signs are the same and match the sign of the middle term. So we would have plus and plus. Factors of our first and third term. Well, for 9x squared, we're going to have x and x. Factors of 9 are 1 and 9 or 3 and 3. Which one do we want? 3 and 3, because if something's going to match on top and bottom, we need 3x. Factors of 4. 1 and 4 or 2 and 2. We'd want the 2 and 2 so that we do get a 3x plus 2 on top and bottom. And if I did check this, 3x times 2 is going to give me 6x. 2 times 3x is also going to be positive 6x. And 6x plus 6x is positive 12x, which is the middle term we wanted. That also means a 3x plus 2 on top and bottom will simplify, leaving us with 3x plus 2 on top. Now, because it is in the numerator, we do not have to write divided by 1. We don't have to write that because it's understood. We can just leave it as 3x plus 2. Because division of 1, it's understood. It doesn't change anything. If it's 1 on top, if we actually have 1 over 3x plus 2, we have to write the 1. 1 has to be written on top. We do not have to write it over 1 on bottom. Questions on this one here? We're going to look at 22. There's not going to be one with 3 terms, not because it's any harder than the 2 terms. It's just more time consuming. Now, 22. Before we start adding or subtracting, we need to factor the denominators as far as possible. We're not so concerned about the numerators, and really we don't need the parentheses, but I'm going to go on and put them anyways at this point. But we want to factor those denominators as far as possible. Now, the x plus 7 does not have a greatest common factor. The degree is 1, so that is as simplified as it gets. Now, our other expression, x squared plus 5x minus 14. There is no greatest common factor between those 3 terms. There's no number, no variable that we can divide out that it has it in common with all three. Third term's negative, so our signs are opposite. Only factors of x squared are x and x. Factors of 14 are 1 and 14 or 2 and 7. Which one do we want to try first? 2 and 7. Which one's positive? Which one's negative? 7 positive and the 2 is negative. Now these are the correct factors and it actually helps us. Because with the 7 being positive, giving us that x plus 7, both denominators already have something in common, yes? That's one less thing I have to multiply both things by to get them to be the same. That helps us more than it being x minus 7. Because if it had been x minus 7, I'm going to have to multiply the left on top and bottom by x plus 7. And we're going to have to multiply the right by x minus 7 and x plus 2. A lot more. With it being plus 7 minus 2, if we do check it, we would get negative 2x plus 7x, which is indeed positive 5x, the middle term we wanted. But it also tells me that if I'm looking for what I need to multiply, if I looked at what the right side has that the left side doesn't, well, that's nothing. Because the right side has x plus 7, the left side already has it. The only thing that the right side is missing that the left side has is x minus 2. So the fraction, our rational expression on the left-hand side, already had everything we needed. We just needed to fix the one on the right so that the denominators were the same. And as we do this multiplication, the left-hand side's going to stay just x squared minus 5. X plus 7 times x minus 2. The denominators, we're just going to put those two sets of parentheses right next to each other, because that is showing that we multiplied them together. And because we're not having to combine like terms, we're not simplifying anything on bottom simpler than that. No reason to distribute it. On top, however, we're going to multiply this out. X times x is going to give us x squared. X times negative 2 is going to give us negative 2x. 3 times x is going to be plus 3x. 3 times negative 2 is going to be negative 6. Because we are going to multiply through the numerators because, again, we have to add or subtract our numerators. We will be doing combining like terms, if there are any like terms to combine. So we will have to multiply through, distribute the numerators to make sure of our like terms. Now, before we start actually combining like terms, adding, subtracting, it would be helpful for us to combine like terms, that negative 2x and positive 3x. Negative 2x plus 3x gives us positive x. Questions on how we got here? Now that the denominators are the same and the numerators are simplified as far as possible, we're going to subtract these two rational expressions. Now I write it first with the parentheses because here we are subtracting. We will have some signs that will change. Now the x squared minus 5 is going to stay the same because there is no sign in front of it. There's nothing we're multiplying through. But our second expression, we're going to have to distribute that negative. And that's going to turn it from positive x squared to negative x squared. It's going to turn it from positive x to negative x. And it's going to turn it from negative 6 to positive 6. And it's still over x plus 7 times x minus 2. At this point here on top, we're going to combine like terms. You can write it underneath. I'm just writing it to the side so I don't scroll again. X squared minus x squared is 0. I've got 1x squared, and I take it away. We don't have any x squareds left. Our negative x does not have any like terms, so it's just negative x. Negative 5 plus 6 is going to be plus 1. And that's actually as simplified as it gets. We could factor that negative 1 out of the top, which is just going to be negative parentheses x minus 1, close parentheses. Still does not match with anything on top and bottom. We can't simplify. If it had been 2 instead of 1, I need to factor that negative out. So we have x minus 2 over x minus 2, which would simplify to negative 1 over x plus 7. But here, this is as far as we can go. Yes. Questions on this here? Least common multiple. Least common multiple. Let's look at 29. 4x squared minus 16 and 6x squared minus 24x plus 24. We'll look at the 4x squared minus 16 first. And the first thing we always want to be looking for is the greatest common factor, something we can factor out of both terms. In this case, it is 4. So we have 4 times x squared minus 4. X squared minus 4 is a difference of perfect squares. And it's going to factor to x plus 2 times x minus 2. I think we've factored that one enough times by this point. I think hopefully by this point you're realizing we have factored a good number of the expression time and time again. They keep showing up. 6x squared minus 24x plus 24. There's a greatest common factor of 6. And if we factor 6 out of all 3 terms, we get x squared minus 4x plus 4. Since the third term is positive, our signs are the same and match the sign of the middle term. So we'd have negative and negative. Factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. Which one do we want? 2 and 2. Because if we check this, we'd get x times negative 2, which is negative 2x. Negative 2 times x is negative 2x. Negative 2 minus 2 is indeed negative 4, the middle term we want. Least common multiple. Let's tackle the coefficients first, our 4 and 6. Four is 2 and 2. 6 is 2 and 3. So we take however many multiples of a factor that it has, whichever one has the most. So we look at the factors, whichever one has the most of that factor, that's how many we take. So 4 has 2, 2, so we need 2 twice. And we could list it out here, and we can say 2 times 2. 6 has 1, 2, but 4 had more, so we don't care about it. 6 has one factor of 3. 4 doesn't have any. So we can say it's 2 times 2 times 3. Well, what is 2 times 2 times 3? 12. 2 times 2 is 4. 4 times 3 is 12. So really, we're going to end up writing it as 12. We don't necessarily want to leave it as 2 times 2 times 3. Now let's look at our expressions. The one on the left has x plus 2 one time. The one on the right has it 0. So the most times it shows up in either expression is once. So we need it one time in the least common multiple. The other expression that the left side has is x minus 2, and it shows up one time. The right side actually has it twice. So how many times do we need it? Twice. So our least common multiple for this here is 12 times x plus 2 times x minus 2 times x minus 2. And yes, we could actually write the x minus 2 as x minus 2 squared instead of writing it out twice. Both work. Questions on least common multiple? Is there another one you want to see? Which one? 26. Oh. We want to factor both of these as far as possible. Now 2x squared is simplified as you get it. It's a single term. Nothing we can do to it. 4x plus 12. First thing we look for is the greatest common factor. And the greatest common factor between 4 and 12 is 4. We factor it out, giving us 4 times x plus 3. Now that expression is factored as far as possible. So now we can look at least common multiple. Now the parts of least common multiple, where we start, what we look at first, really doesn't matter. So if we looked at the parentheses first, the one on the right has the quantity x plus 3 one time. The one on the left has it none. So the most times it shows up is once. So we're going to need it one time. Now we can look at our monomial terms, the terms outside the parentheses. The left has x squared. The right does not, so we need an x squared. Now we need to see what the least common multiple of 2 and 4 is. The first number I can turn both 2 and 4 into, which is 4. 2 times 2 is 4. 4 is already 4. So the least common multiple for this here is 4x squared times x plus 3. Yep. All right. We're going to look at 34 next. Not that 31, 32, or 33 aren't important. We will solve. They are solving. The steps and processes for solving those is not any different than the rest of them. I just want to look at our 3-term expressions. One thing we need to make sure before we start solving or doing anything is that all the denominators are factored as far as possible. If the numerators are factorable, that's great. We don't need to factor them. There's no reason to factor them, especially for just solving equations. Now, inequalities, we haven't talked about those or covered those, but yes, we need to get it equal to 0. We need 0 on one side. We need the numerator and denominator factored for inequalities. Yes. Now, x squared minus 1 will factor. 2x plus 1 times x minus 1. So once we get all three factored, then we could actually find the restrictions. Because once we get them all factored, we can find the values of x that make the function equal 0. And the two places, the two distinct places where we could have 0 is x plus 1 and x minus 1. Now, even though the x plus 1 does show up more than once, we don't have to solve it more than once because x plus 1's value that makes it be 0 is going to be the same. For the x plus 1, we minus 1 from both sides, telling us that if x is equal to negative 1, we'd have a division of 0. It does not work. And for x minus 1, when we solve it, we find out that when x is positive 1, we would get a denominator of 0. It does not work either. Now, the problems that have restrictions that you do need to be careful of, it will actually tell you in the instructions, be careful of your restrictions. In those cases, you'll need to list the restrictions and throw them out if they show up. Questions on how we got here? Now we need to simplify the denominators out. Now we can start one term at a time. I can multiply everything by x plus 1 first, check and see what simplifies, and multiply by more if needed. Now on the far left side, the x plus 1 and x plus 1 will cancel. In the middle, the x plus 1 and x plus 1 cancels. The 3 has no denominator, nothing to simplify. So we're good there. However, the middle term still has an x minus 1 in the bottom of the fraction. So we're also going to have to multiply everything by x minus 1. The fraction on the far left, nothing else will simplify. In the middle, the x minus 1 and x minus 1 will simplify. And that simplifies all of our denominators. We don't have anything left over. And so what we're left with is 4x plus 1 times x minus 1 is equal to 12 plus 3 times x plus 1 times x minus 1. Now we just need to multiply through, simplify down, get it equal to 0, and solve. So the first thing I'd multiply through is on the left. 4x times x is going to be 4x squared. 4x times negative 1 is negative 4x. 1 times x is going to be plus x. And 1 times negative 1 is going to be negative 1. Equals 12. Plus 3. I'm going to wait to multiply by the 3 because we could multiply that 3 with one of the parentheses. We can only multiply it with one of them, not both. So it's better to just leave the 3 out front. We'll multiply it at the end. I'm going to multiply the x plus 1 times x minus 1. X times x is x squared. X times negative 1 is negative x. 1 times x is plus x, and 1 times negative 1 is negative 1. Now if we notice that the x plus 1, bless you, times x minus 1 would indeed give us x squared minus 1. We could have just gone on and replaced it. We didn't have to multiply it out. If we didn't see that, we could still multiply it out, x times x, x squared minus x plus x minus 1, which will indeed get us to x squared minus 1. On the left-hand side, we do need to combine like terms. Negative 4x plus x would indeed give us negative 3x. Questions on this here? Now at this point here, I would not start getting this equation, these equations equal to 0 quite yet, because we still have to distribute the 3 and then combine like terms. Our 3 times x squared is 3x squared. 3 times negative 1 is negative 3. Now we do have like terms on the right-hand side. 3x squared does not have any like terms, so it's just going to be 3x squared. 12 minus 3 is going to be plus 9. Now that we have both sides simplified as far as possible, we still have quadratic terms. We need to get this equation equal to 0. So one of the first things we can do is subtract 3x squared from both sides. And when we do this, we get x squared minus 3x minus 1 is equal to 9. After we do that, we'll subtract 9 from both sides, get this equation equal to 0, telling us that we have x squared minus 3x minus 10 is equal to 0. All of our quadratic equations, especially at this point in solving, are factorable. You're not going to have to use the quadratic formula to simplify and solve as a part of solving. Questions on how we got to x squared minus 3x minus 10? There is no greatest common factor amongst these three terms. So we'll write our two sets of parentheses with 3 spaces. Since the third term is negative, the signs are opposite. Factors of x squared are x and x. Factors of 10 are 1 and 10 or 2 and 5. I'm going to try 2 and 5. And if we check this off to the side, make sure these are the correct factors. X times negative 5 would be negative 5x. 2 times x is plus 2x, giving us the negative 3x middle term that we wanted. Zero product property. If two things are multiplied together to equal 0, one of them has to be 0. For x plus 2, we would subtract 2 from both sides, telling us that x is equal to negative 2. For x minus 5, we would add 5 to both sides, telling us x is equal to 5. Now, because neither one of these values of x was a restriction, they both work. These are our two solutions. Questions on this one here? Questions on 34? You will have a little more space on the test to fit all this in. Yeah. It might make the test seem a little bit thicker, but it's just extra space. I will not say that every problem will need as much space as given, but I gave you extra space just in case. One of them I know for sure. Let's look at 38. Yep. Now, we do need to factor the denominator because x squared plus x minus 6 is factorable. X squared, x, and 6 do not have a greatest common factor. There's nothing that we can factor out of all three terms. Since the third term is negative, our signs are opposite. The only factors of the first term, x squared, are x and x. Our factors of 6 are 1 and 6 or 2 and 3. The ones I would want to try are 2 and 3. 3 positive and the 2 negative. And if we check this, negative 2x plus 3x, or yeah, negative 2x plus 3x would give us the positive 1x that we wanted. Restrictions. The two places where we can get a division of 0 is at x plus 3 and x minus 2. For x plus 3, we would subtract 3 from both sides, telling us if x is equal to negative 3, we'd have a division of 0. It does not work. X minus 2, we would add 2 to both sides, telling us if x is equal to positive 2, we'd have a division of 0. It does not work. So we can't have either one of these here. All right, guys, focus in. Now, what we're going to multiply everything by is going to be x plus 3 times x minus 2. On the far left, the x plus 3 and x plus 3 would simplify. X minus 2 and x minus 2 would. On the far right, the only thing that will simplify is the x minus 2 and x minus 2 on top and bottom. Questions? Yes? No?
No, I got it.
Okay.
I just had to stare at it for a little bit.
Now the left-hand side is kind of nice. So since everything we multiplied it by simplified out, we're just left with the numerator, which is negative 5. On the right-hand side, we're going to get 2 times x plus 3 times x minus 2 plus x minus 3 times x plus 3. So we have several polynomial expressions, or we have two polynomial expressions that are going to have to be multiplied together. Now the -5 is just going to stay there. Now we're going to distribute, multiply through here. So our x times x would give us x squared. X times -2 is -2x. 3 times x is going to be plus 3x. And 3 times -2 will be -6. Plus. X times x is x squared. X times 3 is going to be 3x. -3 times x is going to be -3x. And -3 times 3 is -9. Now we're going to combine like terms. Now our -2x and positive 3x in that first set of parentheses will combine to give us positive 1x. In our second set of parentheses, the positive 3x and -3x will combine to give us 0. They will simplify out, leaving us with x squared minus 9. Now yes, the parentheses around the x squared minus 9, we could drop them at this point. We don't necessarily need them because the number in front of it is positive 1. Now we will distribute the 2 for the other one, giving us 2x squared plus 2x minus 12 plus x squared minus 9. At this point here, we would combine like terms. Giving us -5 is equal to 3x squared plus 2x minus 21. Now that both sides are simplified and we've combined all of our like terms, we're going to add 5 to both sides, telling us that we have 0 is equal to 3x squared plus 2x minus 16. Now there is no greatest common factor amongst these three terms. Yeah. So I'm going to finish this out still. So if you want to stay and finish it, you can. Otherwise, I'd make sure to have it down. Your first part of your test is tomorrow. Now at this point here, the factors of 3x squared, well, we'd have x and x and 3 and 1. Factors of 16, 1 and 16, 2 and 8, 4 and 4. The factors of 16 that we're going to want is 2 and 8. And we're going to put the 8 with the 3x and the 2 with the x, because if we did check it, we would get -6x plus 8x. -6 plus 8 would give us the positive 2 that we wanted.
It won't be too fast, man. It won't be fast. The studio one's so slow. We gotta speed it up, right?
3x plus 8 equals 0. We'd minus 8 from both sides, telling us that 3x is equal to -8. Divide both sides by 3. Telling us x is equal to -8/3. Here we'd add 2. Telling us x is equal to 2. X equals 2 is a restriction, so we throw it out. But that's it.